Whoa, what is happening with my Roblox character right now? Wait, oh my goodness, look at this effect on my character right now. Oh my god, it is very performance heavy, but it's such a cool looking effect. Oh my goodness. The only way I can see this working is if we used a service that basically allows us to create this sort of frame every single millisecond that's in a loop. Okay, but to tell you the truth, I do know what service is causing this to happen, and it's called RunService. That basically allows us to have time management capabilities and also be able to know about script contexts and just to understand more about Roblox's loop by loop structure. If you don't know what any of that means right now, don't worry, I'm going to go over what all that means so that I can help you understand what is happening here. So with that being said, I'm going to go a little more in depth to help you understand more about RunService before we incorporate it inside of Roblox Studio. All right, let's think about this for a minute. I'm going to try and explain to you a little bit of how RunService is structured so that we have a better understanding of it and how we can incorporate this inside of Roblox Studio. Okay, so in the past, we've worked with managing tasks in how they execute and when they execute within a Roblox game. We've done things like task functions with task.wait, task.delay that basically determines when tasks are being executed within a script. We've also done the same thing with coroutines that basically act similar in that regard. RunService basically gives us a better understanding of this hierarchy that happens within a task scheduler. And it's important to know what tasks are executed before other ones so that we can incorporate our own custom tasks to execute in this hierarchy as well. And that is essentially what RunService allows us to do. So I want to now show you this concept of Roblox's frame by frame loop structure as we can see right over here. So we have a frame happening over here, and then we have one that's happening at the end here that's basically just going to loop back to the beginning and it's just going to continue executing. What does all this mean? Well, first we have to ask, what is a frame? A frame is basically a unit of game logic that tells us how much work is being done within a specific frame. Now, I'm not going to lie to you. A frame a frame executes so quickly that you won't even realize that a frame has been executed, because this is where the concept frames per second come in, like, FPS. So when we run things that are 30 frames per second or 60 frames per second, the more frames that are executing per second, the faster, quote unquote, work is being done, because we have more frames to work with when it comes to how much work is being done within a specific time frame of usually per second basis. So when we run tasks, tasks are being ran within each frame, and it goes from one frame to the next frame to the next frame and then to the next frame, and it's just going to keep on going, and it's going to be recorded every single second that's going to be happening. Within each frame, a frame literally passes by every single like half a millisecond, so you won't even realize it happening. And so with this loop by loop structure, this is how we are able to record how much work is being done per time basis. So now that we have that understanding, we need to understand how tasks are organized and executed based on their priority levels. So let's say with our task scheduler. So our task scheduler has all these different types of, priorities when it comes to what task is being executed first and which ones are executed last. So the ones that are executed in purple, these are events that we can actually use with our own tasks with this hierarchy that's happening here. So the one at the very top, this is basically what's being executed first. So we have the user input, and then we go down through this list. So with things like rendering, wait states, garbage collection, physics simulation, and then heartbeat. So obviously we know what user input is. It's basically how we detect input coming from the player. So if I'm moving my character, it's detecting the keys on my player. And then it goes on to this rendering stage that basically shows that, these are tasks that are being run before the frame is even shown into the 3D world. And then we have other things like wait states. So these are the task functions that we've worked with in the past. And then we have things like physics simulation. So basically any work that's being done in the 3D workspace with physics and all that. And then heartbeat, which is its own separate thing that we can actually work with in this hierarchy. So these are things I want you to understand. So with this hierarchy, this is all within the task scheduler hierarchy. And this task scheduler is basically thrown into each and every single frame that's being recorded. So with this understanding of the frame by frame loop and also this task scheduler hierarchy, we're able to get a really good understanding of how tasks are being executed within Roblox and how we can incorporate our own custom tasks within this hierarchy. And that is essentially how this structure works with RunService. I hope this makes sense to you, because with this understanding, now we're going to be incorporating our own customized tasks in this hierarchy with this frame by frame loop structure. So with that being said, let's go ahead and go straight into implementing our own tasks within this hierarchy that we have going on over here. Now that we understand it, let's incorporate RunService inside of Roblox Studio. So I hope my analogy made sense to you when it comes to the frame by frame loop structure and also the way the task scheduler hierarchy goes when it comes to what tasks are done first versus which ones are done last. So the way this is going to work is we're going to create our own custom tasks and execute them using these events that are colored in purple. So we're going to start at the very bottom, which is going to be the slowest, but also the most commonly used one, called heartbeat. Then we're going to step up to stepped, and then finally RenderStepped all the way up here. So the thing that's in common with all three of these events is that they execute tasks very, very quickly, and it's based on the user's performance based on the frames per second loop structure that we had going on up here. So heartbeat is the slowest one, but it's also the most commonly used one. So that's what I'm going to show you right now. So here's what we're going to do. We're going to go to model and we're going to insert a part. Essentially what we're going to do is move this part along the x-axis to constantly move in the negative direction over here so that we can see it happen in real time once we actually run the script. So we're just going to select this. We're going to rename this to heartbeat part. And then we're going to insert a script inside of server script service. So we're going to hit the plus sign, insert a script like this. We're first going to make reference to the heartbeat part. We're going to say local heartbeat part equals workspace wait for child heartbeat part. And more importantly, we have to make sure that we actually have the RunService service declared. So we're going to say local RunService equals game:get service, open close parentheses, RunService, just like this. Okay, so here's how we run our heartbeat event. We're just simply going to say RunService.heartbeat connect function, open and close parentheses. There is one parameter here. It's called delta time. I'm going to go over what this is in just a little bit, but this is the basic structure of how we have our heartbeat event, because this is how we connect an event, just like this. Like we pretty much know this. And so next what we're going to do is say that every single time that this is running, we're going to change the position of the heartbeat part. So heartbeat part.position equals heartbeat part.position plus vector3.new, open and close parentheses. We're going to put in a -1, 0, 0, because -1 on the x-axis will allow this part to go in this direction like this. So if we now go into the game, hit test and hit run, then what we should see with the part is that it's going to move one stud in that direction very, very quickly. Now, once again, heartbeat is running every single frame. So like I mentioned here before, so every single time a frame is being made, then it's going to move the part -1 in the x-axis, and it's going to do it again and again and again and again. And it's going to run very, very fast. Like if I were to visualize how fast this is, we can do a print here just by saying heartbeat like this, and then we go into the game, hit run. If we look at the output, we can see that it's literally firing like hundreds of times. Like this is how fast heartbeat runs. It's actually really insane how fast heartbeat does run. And keep in mind, this is at the very lowest tier of the task scheduler. So if we go up here, it's going to run even faster than the one down here, which is actually pretty insane. So, like I mentioned, the significance of heartbeat is that it's the slowest, but it's also the most commonly used one. And the reason we use heartbeat out of all these other ones is because this comes after physics simulation. So basically, like if we have our player that's already running, that we already had our user input down for, then heartbeat is going to be everything that comes after this. So that's why we use this one out of all these other ones. Now, here's some tips I have for you when it comes to using this and, why we should use it. So if we were to go back to our script, you might think, why don't we just use a while task.wait do like this, and then just copy everything that's in here inside of here. We could do this instead of using heartbeat, but once again, if you imagine where heartbeat is inside of this task scheduler hierarchy, heartbeat is all the way down here, but then we consider what's going to be all the way back here with wait states with task.wait, task.spawn, delay. So you might ask, like, why is there a difference? Like, why is there a significance when it comes to this? Let's imagine this in terms of how the script is handling what's happening here. If we were to use a task.wait for this while true do statement, we are literally pausing execution of the script before we go in and try to execute whatever is going on down here. And this is a fixed length, keep in mind as well. So task.wait with nothing in here could be like 0.00001. This is going to be a fixed number throughout the entirety of the game's duration. But if, let's say, one of the players had bad performance issues with their device, where the frames for them run slower than if we had in comparison to a gaming PC that can run really fast. This can run really fast versus somebody who can run very slow with like their iPhone 4 or something. All of these frames really depend on the performance, and that's why RunService matters so much when it comes to when tasks are being executed, because it's primarily based on the user's performance of the device that they're playing on. So that's why instead of this fixed length, if we were to, let's say, be playing on a mobile phone, then it would drop down to this versus what it would be like if we were playing on a gaming PC like this. It really depends on what device the player is playing on. So that is a really big difference when it comes to heartbeat over using like a task.wait while loop like this. So here's another tip I have for you. I wouldn't encourage you to use heartbeat or any of these other run events throughout the entire duration of the game. I think it's better for you to wrap this in a temporary connection and then disconnect it whenever you don't need to have it anymore. So here's an example. If I were to wrap this connection inside of a local variable by saying local connection equals RunService heartbeat connect function. So as soon as we run the script, we're going to have a variable be set equal to this connection right here, and it's automatically going to fire. So then if we were to, let's say, have a task.wait for about 5 seconds over here, then we're literally going to disconnect this connection so that we can stop heartbeat from continuing after we don't need it for a while. So we're just simply going to say connection : disconnect like this. Like, it literally disconnects the connection that we've created over here by placing this inside of a variable. So what happens now is if we hit run and then we see this change happen with the part moving so fast in that direction for about 5 seconds, it's literally just going to stop right there because we waited 5 seconds. The connection for heartbeat literally stopped after we decided to hit the disconnect on that connection. So this is very effective if you want to temporarily have events be connected, and you can disable them if you don't want that connection continuing anymore after that. So that's another tip I have for you, and I hope you find this to be useful. Okay, but now going back into our heartbeat function, there is this parameter called delta time, and you might ask, what is this thing being passed into the function? Delta time basically tells us how much time has elapsed from the current time versus the time that it took to start the last frame. So if we were to go back into our script, so basically, whenever this frame fires, it's going to detect how much time has passed from when this frame started versus when this frame started. And so this basically gives us a good indicator of how much time has passed in between these two frames. And this is useful for making precise calculations based on the performance of the player's device. And a really good example I can think of this is if I had, let's say, a part here that rotated based on the player's device performance. So if we were to, let's say, smoothly rotate this part, like let's just imagine this part was smoothly rotating, it's going to either move slowly or fast depending on the player's performance. And this is very useful for optimizing the player's experience depending on their device's performance. So that's a really good example I can think of, but we can incorporate this inside of our script as well, and I'm going to show you how we can do this. So instead of having a fixed vector3 value with -1 each time the position is being changed, what we can do instead is create a local variable called distance, and we can set this equal to delta time, and then we can have like a multiplier here just by, I don't know, saying like 10 in this case, and then we can replace the -1 here, which is a fixed number, to distance. And I'm also going to make this multiply by -10 so that it goes in the negative direction. Okay, so now that we have this, let's go into the game and hit run and see what happens. So now that we have this, the part is moving slower than it should be. Oh, well, it's actually like in the way of these frames, my bad. So let me actually just move all of these really quick and then hit run again. So now what we should see is this part is constantly going to be moving in this direction until it just stops after like 5 seconds, because it's now dependent on the player's performance. If the player was having a slower device, then this part would have moved even slower than it should have, versus a faster device, then this part would be moving faster because of it. And if we want to just quickly measure like what the delta time actually is, we can just print this out in the output so that we can see how much time is being elapsed before the other frame. So as you can see, it's a very small number if we decide to use heartbeat over anything else. So those are a few optimization tips that I have for heartbeat, and also the explanation of using delta time. I hope this part has made sense to you so far up until this point. Okay, so the next event is stepped, and this comes in before the physics simulation. And so the main difference between stepped and heartbeat is that stepped is executed before all of the physics in the game is being executed, while heartbeat is executed after all of the physics simulations have been made. So this tells us that if we want to use stepped, this would primarily be used if we want to do something related to physics before executing the actual physics simulation of our 3D world. So in this case, if we wanted to make changes to, like, let's say a C-frame of a part, or if we wanted to move the velocity or just like other things like that, we would use stepped over heartbeat. And another added bonus to stepped is that this executes before heartbeat. So this executes more frequently than heartbeat at a faster rate. So this one works even faster than heartbeat in a basic sense. So let's do a side-by-side comparison with another part in relation to heartbeat part. So I'm going to duplicate this heartbeat part and move it over here. I'm also going to change the colors of these so that we can differentiate between the two, just like this. And I'm going to call this stepped part. So now what we're going to do is go back into our script. We're going to just simply copy this code right here and then paste it down here. We're going to call this connection connection 2, and then we're going to disconnect connection 2 after 5 seconds, just like we did with the first connection, just like this. And then instead of heartbeat, we're going to replace this with stepped. Now, what's interesting about stepped is that this function gives 2 arguments. So not only does it give the delta time, but it also gives the time. I'm just going to call this duration time because time is a reserved keyword based on Roblox's standards. So this time basically tells us that this is how much time has elapsed ever since the game started. But this is how much time has elapsed ever since the last frame was executed. So there is a difference between the two, and you need to make sure that you do know when to use either one of these things. Now, generally, you don't really need time, but I would still say delta time is pretty important. I'm also going to make reference to the stepped part. So I'm going to copy this, paste it like this, and then say stepped part, wait for child, stepped part. I'm going to copy this, and I'm going to find every instance of heartbeat part and replace it with stepped part instead, just like this. Okay, so now that we have this taken care of, let's go and do a race. We're going to do a test comparison of how much time will elapse with this happening. Okay, so as you can see, heartbeat is running faster, but what does this tell us? I thought Stepped was supposed to be faster. The reason this is happening is because Stepped executes a lot faster than Heartbeat does. And whenever we are recording the distance, we are using the delta time from the current frame to the last frame. And so the distance is going to generally be smaller than Heartbeat, but we're going to be executing this position change more frequently than this one. So as a result, Heartbeat executes less, but it has a bigger distance. But Stepped has more execution, but has a smaller distance each time we execute it, which is really interesting. So in essence, when it comes to knowing which one is faster, there's a lot of variables that tie into it, and there's a lot of definitions when it comes to which one is quote unquote faster. So that's why you need to understand this from the perspective of the hierarchy of like, do you need to make calculations before the physics is actually running, or do you need to make calculations after the physics is running? I would say this is what's more important when you're trying to decide which one of the two you need to use. But if worse comes to worse, if you don't know which one to use, just use Heartbeat. Like, there's nothing wrong with using Heartbeat. This is going to be basically for more specific cases if you do need to use them. So that is hopefully an analogy that helped you understand the difference between Stepped and Heartbeat if you decide to use either one of these in the future. So we finally reached the last event on this hierarchy called RenderStepped. And as you can see, this is all the way up here in the hierarchy as being part of the rendering stage of this task scheduling list. So when we use RenderStepped, you can run stuff very fast with this thing, like at a very, very frequent rate. But there's a few things that we need to keep in mind about RenderStepped. So the first thing that's really interesting is that we can only use RenderStepped on the local side. We can't use this on the server side like we've been doing with Heartbeat and Stepped. This can only be done by the local player. So that is one very important distinction to know about when it comes to using RenderStepped, is we can only use it on the local side. And so with that being said, I'm going to show you a demonstration of using RenderStepped using GUIs rather than using parts to move them around using physics and all that sort of stuff. So what I'm going to do is go to Starter GUI, hit the plus sign, create a screen GUI. I'm also going to create a text label like this so that we can see it on our screen. And then I'm just going to align it like right here, like so. And then I'm going to insert a local script inside of the text label. So the first thing I'm going to do is make reference to the text label equals script.parent. And I'm also going to take the RunService declaration, paste that into here. And then I'm also going to take this task.wait statement and also this connection disconnect statement right here. Okay, so now what we're going to do is right before the task.wait statement, we're going to make a variable called local connection equals RunService dot RenderStepped connect function open and close parentheses enter. Now this one only takes in one argument, which is going to be the delta time, which is very similar to our Heartbeat connection rather than our Stepped connection, which has two parameters in there. So now I'm just going to simply calculate a distance. I guess we could just say local distance equals delta time times 100 like this. And so what do we want to do with this distance? Well, what we can do, we can basically rotate this part clockwise based on the player's performance so that we know that RenderStepped is working as expected. So first thing we can do is probably just make a print statement here by saying RenderStepped like this so that we actually know how many times this is being run. And then what we can do is say text label.rotation equals text label.rotation plus distance like this. All right, so in order to test this, we're gonna have to go into the game, hit test, and then we have to hit play so that our actual character is gonna be inside of the game. All right, so now that we have this, we can see that it's constantly rotating from where it started to constantly just go clockwise like this until about 10 seconds where we just disconnect the connection just like that. But as you can see, within this 10-second time frame, it ran very, very frequently. Like, I can't even describe how frequently RenderStepped executed, but it executed very, very frequently. At least I can tell you that. Faster than what Stepped could execute, faster than what Heartbeat could execute. But once again, this can only be executed on the local side. So there are trade-offs to using RenderStepped, but I recommend trying to experiment and figure out which ones work best for you when it comes to knowing which event to use, because RenderStepped, it's all the way up here in the rendering process. So you can decide for yourself whether this is the right step for you to use in your scripts, or if you just want to use stepped or heartbeat. Like, it honestly doesn't really matter too much of a difference which one you use, but it's still good to understand why there is a difference between these three and how this task scheduling hierarchy works. So I hope this part has made sense to you up until this point. So we've pretty much gotten over the basics of time management when it comes to RunService and what it has to offer for executing tasks at specific times during specific occasions that we'd want to execute them. But RunService has something else that we may deem to be useful, and that is knowing the context of scripts being executed. And what I'm trying to get at here is RunService has properties to tell us if, let's say, we're playing the game in Studio, or if this script is being run on the server, or if the script is being run on the client. We can tell based on the context of where the script is being executed. And if that's the case, then we can perform specific tasks based on specific criteria like that. An example I can think of is if, let's say, I was programming a boss battle and it has cutscenes and everything like that, then I'd probably just want to skip the cutscenes if I'm playing inside of Roblox Studio, just so that I can test the boss. And that's just one example. There's so many examples you can probably think of if you want to do something specific with your scripts if you're playing in Roblox Studio versus if you're playing in the actual game. And we can do the same thing with knowing if a piece of code in a script is being executed on the server versus if it's being executed on the client. And this is also very useful for module scripts, which I'm going to show you in just a little bit. So for the rest of this video, I'm going to show you these properties that we can use inside of Roblox Studio. So let's go ahead and go straight into that. Alright, so let's start with something easy, which is basically determining if we are playing the game inside of Roblox Studio or not. So here's how it's going to work. I'm going to go on the right side and just very quickly create a new script. I'm going to call this script context like this. And then what we're going to do is first make declaration to RunService. I can just go to one of my previous scripts and duplicate that, paste it into here. And then here's all we need to say. We can just say if RunService : IsStudio, open and close parentheses, then print player is playing in Studio. And then if we don't do that, then we can say player is not playing in Studio. So it seems very easy, right? We just go into the game, hit test, hit play, and then on the output, what we should see, okay, well, if we just disabled our previous script for a minute, let's go back into the game, and then we should see that player is playing inside of Studio because we are indeed playing inside of Studio. If you were playing in an actual game, then it's just going to go to the else statement and then go down here by saying player is not playing in Studio. And not only do we have checks for if the player's in Studio, we can also check if the player is, I don't know, playtesting, or if they're in run mode, all of these different things. We can check for all of these different contexts if we were to have them inside of a script to perform different things based on the script context. So that's one batch of these functions that I'm going to show you here, and it seems to be very self-explanatory. It's pretty easy. Okay, so now I'm going to show you some other ones, like IsServer and IsClient. Now, if you've been scripting for a very long time and you've been following this series, I think you know the difference between the server and client is. I don't need to explain this. But we can basically check in a single script if we are playing on the server or if we are playing on the client based on the script's execution and which context we are executing this script from. So kind of like what we had before up here, we could just say if RunService : IsServer, then we can print that we are on the server. If we say if RunService IsClient, then we can print or just like do whatever's going to be here if we are playing on the client. So both of these are being checked inside of the context of this script inside of server script service. You kind of have to think outside the box a little bit to really understand and think about when this would be useful. Like, when would you want to check if this execution is happening on the server or if this is happening on the client? I'm going to show you one example of using this that I find to be pretty helpful. So I'm just going to delete this code that we have over here. And what I'm going to do is create a module script on the right side of replicated storage. So I'm going to do the plus sign, I'm going to create a module script right over here. And basically the point of this module script is I'm going to create a function. And this is going to check if wherever this function was executed from, whether that was from the server or the client, are we going to continue with the execution of this function. So I'm going to show you what this looks like. I'm going to say function module dot, we could just say like my function or something like that, open and close parentheses, enter. So what we're going to do is get reference to our run service. I'm just going to copy this, paste this up here. I'm first going to say if run service colon is client, open and close parentheses, then we're just simply going to return this. And then we're going to make a print statement down here by saying my function has been executed. And you can just like have whatever else is happening down here. So let's try and understand what's happening here. When we run my function, it's first going to check if whatever called this function is on the client, then we're just going to return it. Because let's say a hacker is trying to execute that they see inside of this module script. Well, since they're on the client, if they try to activate this function and it sees that it's being activated from the client, then we're just not going to do anything about it. We're just simply going to return it. But if we are executing this on the server, then we're going to drop down here and then continue off with whatever we were trying to do with our function, just execute it like normal. So now I'm going to show you what this looks like if we were to require this module script and try to execute it. So we're going to drop 2 lines down here and say local module equals require game.replicated storage.module script like this. And then all we're going to do is just say module.myFunction, open and close parentheses, just like that. So we are running this on the server. So if we go into the game, hit test and hit play, then what we should see in the output is that my function has been executed because we are playing on the perspective of, well, okay, we're playing in the perspective of the player, but we can see down here highlighted in green, that means this was printed on the server. So my function has been executed by the server as expected. So now let's see what happens if we decide to change IsClient to IsServer instead. So that means this can only be executed on the client. So if we go into the output, we can see that player is playing in Studio, but we do not see the print statement for my function has been executed because we executed this function on the server. So because we are now seeing if we're trying to be on the client, it's just not going to run. And if we try to do this the other way around too, so I'm basically just going to very quickly create a local script inside of starter player scripts. I'm just going to create a local script. I'm going to copy this run service command here and these 2 down here. What I'm going to do is just quickly disable my context script inside of server script service, go into the game, hit test and hit play. So what we should see in the output is absolutely nothing because we are trying to see if we are executing this on the server. But if we do this the other way around with IsServer, then what we should see in the output is finally my function has been executed because we are calling this on the client. And we are seeing in the module script if this is a client or if this is not a server, I mean. If this is a client, then we're going to execute what's going to be down here. You get the idea at this point. You kind of have to think a little bit of how you can incorporate IsServer or all of these other context functions inside of your script. And so that is another really cool and neat thing you can do with RunService that other services do not really provide. So I hope you found this part to be informative as well, and it can benefit you for your Roblox development career journey. I hope you found this episode to be informative. This is one of the more complicated concepts in Roblox Studio development, so if you've made it this far into the series, then I gotta congratulate you on that, because these concepts, they're still going to continuously become more and more difficult as time goes on within the series, and you should be proud of it. So to recap what just happened, we learned about the frame-by-frame loop structure that Roblox has. We learned about the task scheduler hierarchy that happens here. We learned about how we can incorporate our own tasks into the task scheduler, and also how we can run certain contexts inside of our scripts to determine what's being executed and how we can execute the script based on the context of where it was executed from. So with everything that I've taught you in this video, I hope you put it to great use inside of your Roblox scripting. And with that being said, that is pretty much going to be it for this episode. If you want to learn more about time management and also executing tasks during specific times within the game, then I encourage you to watch my core routines video, which I will have a link for you right here in this video. But with that being said, I will see you in the next episode. Take care.